Hey folks, all right, well, this time I want to go through kind of our second week of Lab 1. So assuming that you've already gone through and started Lab 1, you've started working on it, today what I want to do is just recap some of the Git steps that you have to go through a bit. Maybe we'll do a bit of a recap on the approach for using arrays of structs and the syntax that you'll be looking at there, and a little bit of a look at some of the error checking of user input. So kind of a reminder of how you go through and determine if somebody actually entered a valid integer or not, for instance, how you get rid of the garbage that they entered if they did enter something that was a non-integer. So we'll just run through a few of the basics that might come in handy here. And some of this you may have seen, some of it you may not, but it won't be a bad refresher any way you slice it. So again, we're plugging away on Lab 1, and again, just following through the same basic idea. You've already gone off and grabbed the code. Hopefully you've already tried writing some of it, and we just want to go through and tackle some of the other bits and pieces here. So let me get my beast open. So I'm assuming you've logged in and you're moving into your CSCI 161 directory and moving into your lab 1 directory. And again, hopefully from last time around, you've got, the make file for compiling things. You've got your lab1.cpp, your lab1.h, right? And we're going through, and again, whenever we make changes to our lab1.cpp and we recompile and we want to go through and sort of do an updated submission so that the instructor can see it and mark it eventually. Again, the idea is you do your git add lab1.cpp to kind of track the recent changes that you've made in that one. Your git add lab1x for the updated executable. A git commit with that -m option and a little message describing kind of what's new in the changes that you've made. So in this case, again, I'm going to try and put in descriptive examples of the changes that I made. In this particular case, I actually included some demo code for circles and IO. So again, it's a message that meaningfully reflects the changes that you made to the recent files. So this goes through. I've sort of told it to track the changes that I just made. I've taken a snapshot and given it a name, and I'm going to try sending it over so that the instructor's got my most up-to-date copy back on the server. And so that's our git push, and it takes a moment, but it goes off. And again, if you ever want to check this, git status goes through and, oops, you can see that I'm not showing my full screen here. The git status goes through and shows me that my branch is up to date with origin master, so the server side is up to date. Nothing to commit, working tree clean. That means, again, that all of the changes that I've made here have been included. So that's kind of what I want to see. All right, so that was the reminder on the Git side of things. So I want to take a look at some of the pieces of code that might be coming in handy here. So in our lab1.cpp, let's see. I wanted to go through, and again, just as reminders of kind of the declaration process, working with arrays of structs, that kind of an idea. Remember that one of the things this asks you to do is to have your main routine create an array of these circles, right? Circle is the name of the struct that's got the information for a circle in it. Go through, create an array of these things. Again, we want to get into the habit of using constants, so you'll declare some constant for how big an array you've got, and we'll just declare, come up with some name for our array. And so I want to create an array of these circles of that size. Now you'll actually be using the number specified in the lab specs. I think it was 20 if I recall correctly. But again, just as an example. And again, in the main routine, you're going to be doing a bunch of things, but it is going to involve passing off that array of circles to different functions. And just as a reminder, when you do that, all you pass is the name of the array, right? So for instance, print circles expects to get an array of circles to print out and something that tells it how many circles to print. So just as an example here, we're saying, okay, here's the array, and here's how many I want you to deal with. Now, again, in your implementation, you're going to be going through and calling that getNumCircs function or whatever it was called to go off and find out how many they actually wanted to deal with. But whatever value they specified, you'd be plugging in here, not a hard-coded 7. But again, that's the idea. So just syntax reminders if you're rusty on arrays of structs. And again, just in terms of playing with structs, right, we're going to have a whole bunch of different functions. Some of them are taking an array of circles as parameters. Some of them are taking a single circle. Again, if you're past just a single circle, then you can get away with just the C dot and whatever the field name is when you want to work with it. Again, hopefully that is pretty familiar. And if you're dealing with an array of circles, then again, when you want to work with an individual circle, you'll refer to it as array I, or whatever index variable you're using. So in this case, I'll have an example here where I'm going to go off and call display circle on the ith element of the array. So for instance, in print circles, if you had a loop that just went through, all of the circles that you were dealing with and just called display circle on each of them, that would be a pretty typical approach, right? And so you're just saying, okay, well, display circle, right? It expects to get past a single circle, so I'm passing it one element out of the array, right? So it's sending one circle off to get displayed. And you'd be doing some similar things to get the data read into the circle and whatnot. So those were things that I wanted to just refresh. I know you've all had lots of practice with structs by now, but it's been a month or two, so just as a bit of a refresher there. Now, one of the things that not all of you ran across in 160 was the process that you can go through when you're reading input from the user to check if they actually entered something of the right data type or not. So, for instance, you ask the user to enter an integer. Hopefully they do, but it's entirely possible that they enter complete garbage, right? They enter foo or blah or something like that instead of an integer. And so what we want to do is to try and detect that and get rid of the garbage that they entered if they did enter garbage. And so what we're going to do here is keep prompting them over and over and over again until they give us something we want. So in the case of getNumCircs, we wanted them to enter a number of circles that was between 1 and the maximum. So you go off, you prompt the user. There should really be a prompt in here someplace. And tell the user what you want them to enter. So obviously you would put a real message in here. I'm just doing this for the sake of an example. So you're going to spit something out to the user. Please enter a blah, blah, blah. You're going to try reading it in. And if they did enter an integer, that'll work. The value will get stored in numcircles. But if they entered complete garbage, then cin doesn't actually put anything into numcircles, and it just leaves the garbage sitting in the input buffer for the next time you try and read something. So the way we can check that is with cin.fail. So cin.fail returns. So this is a method call that checks to see if cin thinks things are okay or not. And if cin failed, it means no, there was some kind of garbage there. I couldn't read the last thing that you entered. So if that's the case, then we have to kind of clean up this error and get rid of the garbage that's still sitting there stuck in the input. So cin.clear is the one that kind of cleans up the error message, and cin.ignore is the one that gets the garbage and takes it out of the input buffer. So you give it some kind of a size, how many characters you want it to read, a maximum number of characters to get rid of. And what it does is it gets rid of the current line up to a maximum of however many characters you specify. Now, again, in terms of coding standards, remember we're supposed to be using constants, so you'd have some kind of a constant for your line length, and you'd be using that here. And then the \n is basically just telling it, read up to this many characters or until you see one of these, so until you see the end of a line. So these two things together clean up the error and get rid of the garbage, and we should be printing an error message for them. Now, we haven't talked about cout versus cerr versus cout yet, but one of the things that I'm going to be introducing more for Lab 2 is the idea of sending error messages to a specific output stream. So I'm going to start getting into the habit of using cerr whenever I've got an error message to display. And of course, we're going to give them some kind of a meaningful message, letting them know that whatever you entered, that wasn't an integer. You need to enter an integer for the number I'm asking for. Now, if that's not the case, so if cin didn't fail, then it did read something in. So it's read in whatever it was they entered, but we still have to check and see if it's in the right range. So here I'm just checking to see if it's too small, right? If they entered 0 or a negative number. So I'd give them some kind of an error message saying, okay, that was wrong. You have to give me a number between 1 and whatever the maximum is. So again, we give them an error message. In this case, what they entered was a valid integer, so I don't do that clear and ignore, right? Cin didn't fail. I don't do the clear and ignore, but I do give them an error message saying, no, that wasn't any good. You have to try again. And you do something similar for checking to make sure, if they entered something that was too big, something that was bigger than max, we'd also want to go through and say, okay, well, if the number of circles was greater than the maximum, tell them, that was too big. And we're going to have a loop that basically just keeps going through this over and over and over again while the number of circles is invalid. Now, here, I've just said while it's less than 0, that should probably really be a less than 1. Right, if it's 0 or negative, it's no good. But really, we should also have tests in here that say, okay, well, or if it's too big. Num circles is too big. And I better get my brackets right. But we'd like something like this so it says, okay, well, keep on going. Keep doing this over and over and over again until eventually we get something that's in the right range. Now, if they entered garbage in there, that won't have changed num circles, which we started off at 0. So until they actually enter a valid integer that's in the right range, this is just going to keep going through over and over and over and over again. So that is probably the other thing that might be new to some of you. This is the kind of approach that you can use for error checking to see if they've entered something that's actually of the wrong data type, so a data type that you don't want. It's not bulletproof. There are still some holes in this, but we'll come back and talk about those in bits and pieces as we get the chance. So those were the big things that I wanted you to have a look at, and you're going to sort of, anytime you make changes, you're going to compile it and see if things are compiling okay. This looks like it compiled okay other than the warnings, but again, there's still a whole bunch of functions in there that we haven't completed, and that's why we're getting all these messages about unused parameters, because again, the function's not done yet. So those will hopefully be gone by the time we actually finish our implementation. And again, I've changed this, so I'm going to do my git add. You don't have to do this on every single individual change, but just as a reminder of the process. Git add my lab1x, git commit -m, one more example of add commit, or add commit push, and a git push. And again, you can do that as often as required. You don't have to do it for every single change, but just as our example here. Okay, those were the big points that I wanted to get through. Let me know if you have questions. Let me know if you're running into problems, right? Catch me on Discord, fire me an email, and we'll see how, or catch me in the Zoom sessions, and we'll see how we go here. All right, good luck, folks.